Hello, welcome. We are in Unit 7, and in this video we'll be going through Lesson 7.1. We're just going to cover the first part of this lesson in this video, so check the second part in the Day 2 video. In Lesson 7.1, we're going to start exploring some properties of powers, and in this video we'll cover the first 3 properties out of the total 5 that we'll learn. Before we jump into the properties, though, we do want to be familiar with 3 vocabulary words and kind of the differences between them. When we see something like this, x to the 4th power, this whole thing is what we would consider a power. So I circled this and we would refer to that as a power. And a power is made up of 2 parts. We have the x here. The x is what we would call the base. That is most often a variable, but could also be a number. We could do 2 to the 4th power, or like in this example, we have a variable to the 4th power. And then our superscript, this number up above, that is what we would call our exponent. So we have a base raised to an exponent, and that in total gives us a power. So we do want to just be careful about the differences between bases and exponents, and then the whole thing would be considered a power. All right, we'll take a look at our first property. Our first property is what we call a power to a power. Now, as we go through these properties, we're going to kind of consider a long version of what this property is showing us, but then we're going to come up with a shortcut that we can use as we're simplifying. So what we see here is we have a power, x cubed, and it's actually raised to another exponent. So this x cubed kind of becomes the base for this power of 2. Now, if we think about what it means to square something means to multiply it by itself. So really what this is saying is if we're doing this thing squared, we would be doing x cubed times itself. So that would mean we're doing x cubed times x cubed. And if we're cubing something, that means we're multiplying something by itself 3 times. So x cubed would actually be x times x times x. That would be my first x cubed. Then we're multiplying that by my second x cubed, which would be another x times x times x. Now, if we think about this in a simpler way, instead of writing x times x times x times x times x times x, there's 6 x's there, so we could rewrite this as x to the 6th power. Like I said, we don't want to have to go through this whole process of writing out all of these x's, especially if we were working with larger numbers. So we're going to see if we can figure out a shortcut. When I take a look at my numbers here, we started with a power of 3 and a power of 2, and we ended with a power of 6. So if we think about how we could take 3 and 2 and get to 6, we could multiply those exponents. So our shortcut is going to be that whenever we have a power, we're going to take and multiply our exponents together. We'll take a look at a couple examples of these properties. In my first example here, we have an n cubed to the power of 7. So again, instead of having to write out all those n's, we could just take and we could multiply those exponents. 3 times 7 would be 21. Sometimes we might have multiple bases. For example, here we have an a and a b. We would have to apply that 5 to both. So I'll apply the 5 to the a, and if we do that, we could multiply 4 times 5 would be 20. And we would also have to apply it to the b. Now that b doesn't already have an exponent, so that means it's just going to turn into a 5 when we multiply that. And that would be our answer. Now, when we look at example 3, we do want to be careful. This 4 is not an exponent. In this case, 4 would actually work as a base. And if 4 is a base, we actually have to distribute that power to that base of 4. So I would actually get 4 to the power of 2. Notice that I'm not multiplying 4 times 2. We're applying it as an exponent to that base. We could then distribute it to the k. Now this is an exponent, so with our exponent we would actually multiply. 2 times 2 would give us k to the 4th power. Now in something like this, when we have a 4 squared, that's going to be a number, so we could actually find that. 4 squared would be 16, and then we could just leave our k to the 4th. So that would be the simplest version. Again, in number 4, we can see we have multiple bases here. We have a 5, we have an x, we have a y, we have a z. So this 3 that's outside of the parentheses is going to have to be distributed to every base inside the parentheses. That does include the 5. And again, 5 here is not an exponent, meaning we're going to put that 5 as a base, and 3 just becomes that exponent. For x, this is an exponent, so we'll do 3 times 3, which gives us 9. For the y's, we'll multiply 5 times 3, which will give us 15. And the z doesn't have an exponent, so we'll just put that 3 as our exponent. And again, similar to our last example, when we have that number here, that 5 cubed, we could go ahead and do that. 5 times 5 times 5 would be 125. We can leave the x and the y and the z. You can put little dots for multiplication if that's helpful for you to separate your bases, but we also don't have to, because just writing variables next to each other like that also means multiplication. All right, we'll go ahead and take a look at our second property. Our second property is if we're multiplying 2 powers. Now, notice here that we have 2 separate bases and we're multiplying those 2 bases. So it's not like we have parentheses with an exponent outside that we're distributing. Again, if we kind of think about the long version of this, if I have an x cubed, cubed means we would be multiplying x by itself 3 times. And we're multiplying that by x to the 4th, which would be x by itself 4 times. And again, we don't want to have to write this out every time. That would be a lot of x's. So we'll go ahead and see if we could simplify. If I count, we can see that we have 7 x's here. So that would be x to the 7th power. Again, though, we would want our shortcut. And our shortcut, if we take a look at the exponents we started with a 3 and a 4, and we ended with a 7. So if we think about what operation we could use, 3 plus 4 would equal 7. So our shortcut here will be to add the exponents. So if we're multiplying powers, we can go ahead and add the exponents together. If you flip, we'll take a couple examples of multiplying powers. So here we see we have the same basis, m3 and m8. If we add those together, 3 plus 8 would give us 11. Now, in number 2, we might be tempted to go back to the property we did before, but we can see that there's not an exponent outside of the parentheses here, which means those parentheses are really just going to function like multiplication. It's like I had 6b squared times negative 3b to the 4th. Those parentheses really just mean we're multiplying. Now, with the 6 and the negative 3, 6 and negative 3 are not exponents. So we don't want to add those together. We're not using our shortcut because they're not exponents. We'll just do this operation, and this operation is multiplication. So we'll take 6 times negative 3. 6 times negative 3 is negative 18. However, with our exponents, we can use our shortcut. So we could add 2 plus 4 will give us 6. In number 3, we have multiple bases. So we have g's and h's. And again, these parentheses would be the same thing as if we were just multiplying. So we don't have to worry about distributing anything here. When we have multiple bases, we want to make sure we combine the exponents of similar bases. So I'm going to combine my g's together. Now, this g here doesn't have an exponent, so we could think of that as a 1. If you need to write that in there to remind yourself, that's a 1. So if we add 2 plus 1, we'll get 3. And our h's we can combine. 3 plus 5 will give us 8. And our last example, again, similar to number 2, we do want to be careful of our coefficients. That 7 and 5 are not exponents, so we're not using our shortcut. We would simply do the operation, which 7 times 5 would be 35. Our x's we could combine. Here we have a 4, and here we have a 3, so we could add 4 plus 3 would be 7. And our y's, we could combine. 4 and 5 will be 9. And that would be our answer. All right, and our final property for today is going to be dividing powers. Again, we'll take a look at this with a longer version and see if we can come up with a shortcut. When we're dividing, we're going to use fractions to represent division. So if you see a fraction, we should think division. Here, in our first example, we have x to the 6th, which means we would be multiplying 6 x's. So I would have 6 x's on top of this fraction. And on the bottom, we have x to the 4th, so I would have 4 x's with this fraction. Something we know to be true about fractions is if we have the same thing on top and bottom, those things will actually cancel each other out. So any pairs of x's where I have a matching one on top and bottom, those would actually cancel and go away. Out of my pairs, 4 cancel and we're left with 2 x's, so I could write that as x squared. If we try to find a shortcut, if we take a look at our original exponents here, we had a 6 and a 4, and we ended with 2. So if we think about that, we could subtract. 6 minus 4 would equal 2. So when we're dividing 2 powers, we will subtract the exponents. All right, and we'll take a look at just a couple examples of this. In number 1, again, we're dividing, so we can subtract. 9 minus 5 will be 4. Number 2, here we can subtract. Again, we're going to combine like bases, so we'll combine the g's. 6 minus 5 is 1g. We don't have to write the 1, but you could if you wanted to. Just typically an exponent of 1 we don't write. We could combine the h's. 10 minus 4 would be 6. Number 3, we want to be careful, again, with these numbers out in front. 16 is not an exponent, and 8 is not an exponent, meaning we can't use our shortcut. So not subtracting, we would just do the operation that we see. That would be division. So we're doing 16 divided by 8. 16 divided by 8 is 2. Combining like bases, our a's will subtract. 5 minus 2 is 3. B's, we can subtract. 9 minus 3 is 6. And C's, this C down here, again, if we don't have that written, we could think of that as a 1. So we could do 4 minus 1, which is 3. And our final example, again, here we have that 24 and negative 8. Those are not exponents, so we're not using our shortcut. We're going to go ahead and actually divide those. 24 divided by negative 8 is negative 3. For the p's, we can subtract. 7 minus 4 is 3. And the r's, if we do 9 minus 9, now 9 minus 9 is 0. We could put r to the 0 power. We're going to talk more about 0 powers in our next video, but really those are just going to go away. If we have the same thing on top and bottom, those will just go away, so we actually don't need an r in our answer. That means negative 3p cubed would just be our answer. For the next 2 properties in this lesson, go ahead and find the lesson 7.1 day 2 video.